The speed of different chemical reactions varies hugely. Some reactions are very fast and others are very slow. The speed of a reaction is called the rate of the reaction. What is the rate of these reactions? For example, rusting, it has a slow rate. Explosion, very fast. Chemical weathering of rocks, very slow. Reaction between sodium and water, fast. Rotting of fruit, slow. Reactions take place when particles of reactants collide with a certain amount of energy. This energy is called activation energy and is different for each reaction. The rate of a reaction depends on three things. Number 1, the frequency of collisions between particles. Number 2, the energy with which particles collide. Number 3, the geometry with which particles collide. If particles collide with less energy than the activation energy, they will not react. The particles will just bounce off each other. Anything that increases the number of successful collisions between reactant particles will speed up a reaction. What factors speed up the reactions? Number 1, increased temperature. Number 2, increased concentration of dissolved reactants and increased pressure of gaseous reactants. Number 3, increased surface area of solid reactants. Number 4, use of a catalyst. Measuring the rate of a reaction means measuring the rate of change over a period of time. This means measuring the change in the amount of a reactant or the amount of a product. What can you measure to calculate the rate of reaction between magnesium and hydrochloric acid? Number 1, the amount of magnesium used up. Number 2, the amount of hydrochloric acid used up. Number 3, the amount of magnesium chloride produced. Number 4, the amount of hydrogen gas produced. Reactions do not proceed at a steady state. They start off at a certain speed, then get slower and slower until they stop. As the reaction progresses, the concentration of reactants decreases. This reduces the frequency of collisions between particles and so the reaction slows down. Effect of temperature on the rates of reaction. The higher the temperature, the faster the rate of a reaction. In many reactions, a rise in temperature of around 10 degrees Celsius causes the rate of reaction to approximately double. Why does increased temperature increase the rate of reaction? At a higher temperature, particles have more energy. This means they move faster and are more likely to collide with each other. When particles collide, they do so with more energy, and so the number of successful collisions increases. Effect of concentration on the rates of reaction. The higher the concentration of a dissolved reactant, the faster the rate of a reaction. Why does increased concentration increases the rate of reaction? At a higher concentration, there are more particles in the same amount of space. This means that particles are more likely to collide with each other. Why does increasing the pressure of gaseous reactants increase the rate of reaction? As the pressure increases, the space in which the gas particles are moving becomes smaller. The gas particles become closer together, increasing the frequency of collisions and so increasing the rate of reaction. Effect of surface area on the rates of reaction. Any reaction involving a solid can only take place at the surface of the solid. If the solid is split into several pieces, the surface area increases. This means that there is an increased area for the non-solid reactant particles to collide with. The smaller the pieces, the larger the surface area. This means more collisions and a faster rate of reaction. Effect of catalysts on the rates of reaction. What are catalysts? Catalysts are substances that change the rate of reaction without being used up in the reaction. Catalysts are very important in industry because products can be made more quickly, saving time and money. They can also avoid having to use high temperatures, so they can save fuel and reduce pollution. Catalysts are also very important in living cells. Biological catalysts are special types of protein called enzymes. Example of catalysts. Many catalysts are transition metals or they are compounds. Different reactions use different catalysts. For example, nickel is a catalyst in the production of margarine. Iron is a catalyst in the production of ammonia from nitrogen and hydrogen. Platinum is a catalyst in the catalytic converter of car exhaust. It catalyzes the conversion of carbon monoxide and nitrogen oxide into the less polluting carbon dioxide and nitrogen oxides. How do catalysts work? For chemical reaction to take place, energy is needed to break existing bonds, so new bonds can be formed. The reacting parts of particles need to be brought together. Different catalysts work in different ways, but most solid catalysts work by lowering the amount of energy needed for the reaction to take place. Catalysts work by lowering the activation energy of a reaction.